Welcome back. This is Chapter 11, Assignment Number 2. Our learning target today is I will be able to find the area of trapezoids, rhombi, and kites. Don't forget to be an active participant, so get your notebooks out and let's get started. So the first quadrilateral that we are going to be looking at today is a trapezoid. And if you recall, we recently studied quadrilaterals and we learned that a trapezoid has exactly one pair of parallel sides that are called bases. So on my screen I have a trapezoid drawn and I have one pair of parallel bases that I have in blue. Notice that I have the two arrow markings that show that those are parallel. The other two sides of the trapezoid I have in pink, and those are called the legs. So I am going to label my two parallel bases B sub 1 and B sub 2, and that just stands for base 1 and base 2. It does not matter which order that you label them in. I usually start at the top and label that one B sub 1 and the bottom is B sub 2, but you could switch them around and it would still be okay. In my trapezoid I also have the perpendicular distance, and I have that colored in green, and that is the height of the trapezoid because that is the distance between the two bases and it forms a right angle, so it's the perpendicular distance. Our trapezoid area formula is B sub 1 plus B sub 2 in parentheses times h divided by 2. So I'd like to do a little demonstration to help you make sense of this area formula for a trapezoid. If you recall, when we studied trapezoids, we learned about the midsegment of a trapezoid. The midsegment connects the midpoint of one of the legs to the midpoint of the other leg, and it is parallel to the other two parallel bases. So notice that this midsegment divides the trapezoid into an upper piece and a lower piece. I'm going to take this upper piece and I am going to duplicate this, and I'm going to actually move it over to the right, and I'm going to flip it upside down, and then I'm going to line it back up with the bottom portion of that where we had the midsegment. So I'm just going to put this midsegment back in, and you can see that when I lined up that top portion from the midsegment up, and I slid it over to the side, I turned it upside down, and I moved it right up against the bottom portion, notice that that creates one long skinny parallelogram. So let me do something here. Let's make this upper part here kind of disappear. Let's just kind of erase this so that you can see this long skinny portion. And I will actually even highlight that, the whole thing orange. So you can see that I have a parallelogram here, very long and skinny, but recall from the first area video that we did that the formula for a parallelogram is base times height. So what is the base of this long skinny parallelogram? Well, it consists of this B sub 1 over here and the B sub 2 over here. So I have B sub 1 plus B sub 2 is now the entire base of this long skinny parallelogram. And the height of this is this green portion here. You can see this green height here, but that's actually only half of the original height we had in our full trapezoid that we originally had. So the area of this parallelogram is B sub 1 plus B sub 2 times the height, which is just the original height divided by 2. So that is how we get the trapezoid area formula as b sub 1 plus b sub 2 times the height divided by 2. So moving on to the next quadrilateral, that is a rhombus. And with a rhombus, we know that one of the properties is that all of the sides are congruent. And in my rhombus that I have drawn here, I also have the two diagonals drawn. I'm going to name the length of the horizontal, in this case it's the shorter of the diagonals, I'm going to name that d sub 1 or diagonal 1. And the second diagonal, which is my vertical one going up and down, the length of that I will name d sub 2. The area formula for a rhombus is d sub 1 times d sub 2 divided by 2. So I'm taking the length of the two diagonals that are inside the rhombus, I'm going to multiply them together and divide it by 2. And finally, let's look at the final quadrilateral in this area video, and that is a kite. So on my screen I have a kite drawn. I have it sitting upright like you would normally think of a kite if you were going to fly it in the sky. Recall that one of the properties of a kite are that adjacent or consecutive sides are congruent. So my two upper sides I have marked as congruent with 1 tick mark each, and the two longer of the sides I have marked congruent with 2 tick marks each. I also have the diagonals drawn, so in this case my shorter diagonal, which is my horizontal diagonal, is labeled d sub 1, the length of that, and my vertical diagonal is labeled d sub 2. Now the nice thing about a rhombus and a kite is that they both share the same area formula. So the formula for the area of a kite is also d sub 1 times d sub 2 divided by 2. So you take the product of those two diagonals and you divide it by 2. So I would like to do one more demonstration. This demonstration I will do on the kite, but you could also do it on the rhombus as well. And I just would like to show you why this area formula makes sense. So I'm going to take the right side of my kite. So notice that this vertical, the longer of the two diagonals, divides this kite into 2 equal parts. So if I take this and I'm going to divide it in half, that right half consists of a smaller triangle on the top and a larger triangle on the bottom. So I'm going to take this, the smaller of the two triangles, and I'm going to copy that over, slide it over to the left. And then I'm going to take a copy of that longer, the bigger triangle on the bottom, and I'm going to slide that also to the left. Now let's erase this right-hand half of my kite. Now it looks like a butterfly, but I have now the right-hand side is now over to the left, and they're kind of facing each other in a funny sort of way so that it looks like a butterfly. But I'm going to take both of these triangles, I'm going to take both of them and flip them upside down, and then I'm also going to flip them left to right. And I will do the same thing with the bottom one. I'm going to rotate that upside down, and then I'm going to flip it from left to right. And then notice I can take both of these triangles and line them up with that left-hand side of my original kite. And when I do that, notice what I have. I'm going to highlight that in yellow. I have a tall, skinny rectangle. And you can recall from the first area video that the area formula for a rectangle is base times height. So let's see how that area formula for a rectangle can be used for this yellow rectangle. And remember, this yellow rectangle does represent the entire area of that original kite that I had, because I just copied that right-hand side and moved it over to the left and lined it up after I flipped them around. So the area of this yellow rectangle is base times height. So my base is going to be half of this first diagonal, and my height is going to be the length of this vertical diagonal. So if I take base times height, I can multiply these two together, but remember that the base is only half of what the original was, what the original diagonal was. So now you can kind of see how this area formula makes sense. I can multiply the half of diagonal 1, which is my base, times diagonal 2. So hopefully that demonstration will help you remember this formula a little bit better. So before we get to working some examples to find the area of these quadrilaterals, let's look at our organizer. So now is a good time, if you haven't done any notes yet, take out your notebook and you should be writing these down. Again, similar to the first video, we have 3 columns. The first column, I have the name of the polygon. The middle column, I have the area formula. And the third column, I have drawn a diagram, and you should also be labeling these. So let's start with the trapezoid. The area formula for a trapezoid is b sub 1 plus b sub 2 times h, all divided by 2, where b sub 1 is my base 1, b sub 2 is my base 2, and h is the height. So in my little diagram here, I have drawn a trapezoid. I label one of the bases as b sub 1, the other base I label as b sub 2, and those are the parallel sides of my trapezoid. And then the perpendicular distance I have labeled as h. Make sure that you draw in your right angle there so that you can see that it's perpendicular. So again, the height is the perpendicular distance between those two parallel bases. And then finally we have a rhombus and kite. The area formula for both of those is d sub 1 times d sub 2 divided by 2, where d sub 1 is diagonal 1, d sub 2 is diagonal 2. And it doesn't matter which diagonal you label as d sub 1 and which one you label as d sub 2, because you're just taking the product of both of those and dividing that product by 2. So for my rhombus, I have drawn a quadrilateral that has 4 congruent sides, so mark those sides as congruent. And for my kite is laying on its side, and again label the 2 diagonals d sub 1, d sub 2. If you need to pause the video here or rewind a little bit to make sure that you get all of these formulas in here, now is a good time to do that before we start working our examples. So on our example page, they are asking us to find the area of each polygon. Remember, when you're working through area problems, you need to ask yourself 2 questions. First, what type of polygon do you have? So look at each of the polygons and try to name what they are. And number 2, then decide which formula should you be using for that polygon. Now is a good time, if you would like to to try these on your own. So pause the video and work through these and see if you can get the answers to these, and then come back and watch me work them. So the first diagram that I have on this slide is a quadrilateral, and it has one pair of sides that are marked parallel. And you may say to yourself, looking at this, this looks like a parallelogram. But notice that one of the parallel sides is 5 centimeters. The other parallel side is marked as 6 centimeters. And we know that a parallelogram would not only have opposite sides parallel, but those lengths would be equal to each other. So this is not a parallelogram. This, in fact, is a trapezoid. And what formula do we use for a trapezoid? We have area equals b sub 1 plus b sub 2 times h divided by 2. So in this case, b sub 1 is going to be 5 centimeters, b sub 2 is going to be 6 centimeters, and then I'm going to highlight this perpendicular distance between those two parallel bases in green, and that is 3 centimeters. So let's find our pen and let's work this together. So I have my area equals b sub 1 is 5, b sub 2 is 6, times my height, which is 3, and that all gets divided by 2. So my area equals 5 plus 6 is 11, times 3 divided by 2. So I have 33 divided by 2. And I can make that into a decimal, so get your calculator out. 33 divided by 2 is 16.5. And remember that the units that they used for the length of the sides and the height was in centimeters, so we are going to have centimeters squared. So our area is 16.5 centimeters squared. Now, if you would have taken this area formula that you had right away, that A equals 5 plus 6 in parentheses times 3 divided by 2, and had you put that in the calculator but did not use parentheses, you would not have gotten the correct answer. So please be careful if you're going to be plugging this entire formula into your calculator without doing the intermediate steps like I did, where I added the 5 plus 6 to give me 11. If you plug this in, please use parentheses, because otherwise you will not get the correct answer. All right, let's move on to the second diagram. And in this diagram, I have a quadrilateral where all 4 sides are marked as congruent. So I know that that is a rhombus. And the formula for the area of a rhombus is d sub 1 times d sub 2 divided by 2. Now, one of the properties that you would need to remember for a rhombus is that the diagonals are perpendicular, and they're marked as perpendicular, but they also bisect each other. So in this diagram, my horizontal diagonal, just the left hand of it, side of it, is marked as 8. And my vertical diagonal, just the bottom portion, is marked as 7. So I know that if the bottom portion is 7, that top portion is 7, so my whole length of my vertical diagonal is 7 plus 7, which is 14. And then I also know that if this half on the left for my horizontal diagonal is 8, the right half also is 8. So the entire diagonal is 16. So let's get our pens, and I now have the area equals diagonal 1, which is 14, times diagonal 2, which is 16. So we have 14 times 16, all of that divided by 2. Get your calculators out. 14 times 16 divided by 2, 112 units squared. They did not give us any units in this example, so we would be using u squared. Finally, let's look at the last one. In this case, we have a kite that is tipped on its side, and we know the area formula for a kite is d sub 1 times d sub 2 divided by 2. In this case, our diagonal 1 is going to be 3 plus 3. That vertical diagonal has 2 pieces to it, 3 meters and 3 meters, so that would be 6. And the longer diagonal consists of 4 plus 9. That was the longer horizontal. So we have area equals 6 times 4 plus 9 is 13, all divided by 2. And I'm not even going to need my calculator because I'm going to do the 6 divided by 2 is 3. And 3 times 13 I know is 39. And our units are meters squared. So you could either have plugged in 6 times 13 divided by 2 in your calculator to get 39, or you could see that you could have done the 6 divided by 2. So those are our 3 examples. Hopefully now you feel confident with the learning target. I will be able to find the area of trapezoids, rhombi, and kites. So now that we have finished this, the next step would be to complete the Chapter 11 assignment number 2 homework. That is found on Schoology and the Chapter 11 folder. Again, this homework, just like the assignment number 1, is found in Schoology and not on Delta Math. So thank you for listening, and as always, I hope you have a great day and stay safe. See you later.